Picture this. It's 1951, and you're standing in a garage in Daytona Beach watching a mechanic pour what looks like liquid sandpaper into an exhaust manifold. The other crew chiefs think he's lost his mind. 6 months later, that same mechanic's cars are mysteriously pulling away from everyone else on the straightaways, gaining car lengths where it shouldn't be possible. The NASCAR officials tear the engine apart looking for illegal modifications. They find nothing, because technically there weren't any. This is the story of how Smokey Yunick, a B-17 bomber mechanic turned racing genius, discovered a loophole so brilliant that NASCAR had to rewrite their rulebook again. See, Smokey had a gift for reading rules the way a lawyer reads contracts, looking for what wasn't said rather than what was. And in 1951, what wasn't said would add 50 horsepower to his Hudson Hornets using nothing more than an air compressor, some valve-grinding compound, and the kind of creative thinking that made him the most feared and respected mechanic in NASCAR history. To understand why this hack was so revolutionary, we need to talk about what Smokey was working with. The Hudson Hornet dominated NASCAR from 1951 to 1954, winning 79 races in a 4-year stretch that remains one of the most dominant runs in racing history. At the heart of these beasts was Hudson's legendary 308 cubic inch inline-six engine. Yes, a straight six beating V8s. The engine featured a unique L-head design where the valves sat beside the pistons rather than above them. Stock, it produced 145 horsepower. But here's the thing about early 1950s manufacturing. Quality control was more suggestion than science. The exhaust manifolds Hudson produced were rough, and I mean rough. The casting process left the internal passages looking like the surface of the moon, pitted, uneven, with casting flash and restrictions that choked exhaust flow. Every mechanic knew these manifolds were costing them power. The exhaust gases had to fight their way through passages that looked like they'd been carved by a drunk mole. The turbulence alone was probably costing 20 horsepower. Now every decent mechanic knew the solution. You'd take a die grinder with carbide bits and spend hours smoothing out those passages. Port and polish, they called it. Open up the restrictive areas, smooth the transitions, polish the surfaces until exhaust could flow like water through a pipe instead of chunky peanut butter through a crazy straw. On a good day, proper porting could free up 30 to 50 horsepower on these Hudson engines. But here's where it gets interesting. NASCAR's rulebook in 1951 was specific, very specific. Rule 12, Section 4, Paragraph B, clearly stated, exhaust manifolds must remain stock as delivered from the manufacturer. No grinding, cutting, welding, or mechanical modification of the exhaust passages is permitted. The France family, who ran NASCAR, wanted stock car racing to actually use stock parts. The cars fans saw on Sunday should be the same ones they could buy on Monday, at least in theory. The rule makers thought they'd covered everything. No grinding meant no die grinders. No cutting meant no enlarging ports. No mechanical modification meant you couldn't touch those passages with any tool. Case closed, right? Smokey Yunick read that rule 20 times. Then he read it again. Then he smiled that famous smile that meant someone was about to get outsmarted. The rule said no mechanical modification. It said nothing about chemical modification. Smokey had spent World War II maintaining B-17 Flying Fortress bombers. These planes had massive turbo-supercharged Wright R-1820 radial engines, and keeping them running at 25,000 feet over Germany taught you things about airflow that no racing manual could match. He'd learned that smooth airflow was everything at altitude. A rough intake passage could cost you 50 horsepower when you needed every single one to stay airborne with 2 engines shot out and German fighters on your tail. But more importantly, he'd learned about maintenance procedures the Army Air Forces used, including how they cleaned and maintained complex aluminum castings without disassembly. They used abrasive compounds pumped through passages under pressure, the same principle as sandblasting, but with a controlled medium that could polish as well as clean. So what was actually going wrong inside those Hudson manifolds? When cast iron cools in a mold, it doesn't cool evenly. The surface against the sand mold cools faster than the interior metal. This creates a rough, crystalline surface structure with high points and valleys. Under a microscope, it looks like a mountain range. Every one of those peaks creates turbulence. Turbulence creates back pressure. Back pressure kills power. The exhaust valve opens, and a pulse of gas at 1,500 degrees Fahrenheit tries to escape. In a smooth tube, it flows in what engineers call laminar flow, organized, efficient, fast. In Hudson's stock manifolds, it hit those rough surfaces and turned into turbulent flow, chaotic, slow, creating eddies and dead zones. The exhaust literally fought itself trying to get out. Here's where Smokey's genius kicked in. He mixed valve grinding compound, essentially liquid sandpaper, with particles of silicon carbide suspended in oil, with lightweight machine oil to thin it out. Then he sealed one end of the manifold and connected an air compressor to the other, but not directly. He rigged up a reciprocating valve system using parts from an old refrigerator compressor that would reverse the airflow 20 times per second. The compound would rush through the passages in one direction, then immediately reverse. Back and forth, the abrasive particles scrubbing every surface they touched. The high points got hit first and worn down fastest. The valleys gradually filled with worn material and got flushed clean. Over 8 hours of continuous cycling, those rough passages transformed into smooth, polished tubes. Think about that for a second. No tools ever touched the inside of the manifold, no grinding wheels, no carbide bits, no files, just fluid dynamics doing the work. The manifold remained technically, legally stock. Every dimension was still factory. The ports were the same size, the mounting surfaces untouched. If you measured it with calipers, it matched the blueprint perfectly. But the surface finish, night and day. Where stock manifolds had a surface roughness of 250 to 300 microinches, Smokey's chemical porting brought it down to maybe 50 microinches. For reference, that's almost as smooth as a mirror. The exhaust gases that previously tumbled and fought through rough passages now flowed like water through glass. The difference on the dyno was staggering. Where a stock Hudson 308 made 145 horsepower, Smokey's chemically ported versions were putting out 195 to 200, 50 horsepower from what was essentially industrial-grade toothpaste and an air compressor. That's a 35% power increase without changing a single part. Let me put that in perspective. In 1951, the difference between winning and finishing 10th was often less than 10 horsepower. 50 horsepower was like showing up to a knife fight with a machine gun. On the long straightaways at Daytona Beach, where races were still run on the sand and road course, Smokey's Hudsons would pull away from identical cars like they had rockets strapped to them. The first time NASCAR technical inspector Norris Friel tore down one of Smokey's engines after a suspicious win, he spent 3 hours going over every component. Displacement checked out at exactly 308 cubic inches. Compression ratio was stock 7.2.1. Camshaft was factory specification. Carburetor jets were standard. The exhaust manifold was dimensionally perfect. But Norris wasn't stupid. He could see his own reflection in those exhaust passages. He knew something had been done. He just couldn't prove it violated any written rule. And in 1951, NASCAR, if it wasn't explicitly illegal, it was legal. Smokey stood there with his arms crossed, that famous cigar clamped in his teeth, daring anyone to show him where in the rulebook it said he couldn't chemically treat cast iron. The beauty of the trick wasn't just that it worked. It was that it was almost impossible to police, even if NASCAR wanted to. How do you prove chemical porting versus a really good factory casting? Hudson's quality control was so inconsistent that some manifolds came from the factory better than others. Smokey could always claim he just hand-selected the best stock pieces. Good luck proving otherwise without a microscope and a surface roughness tester, neither of which NASCAR had in 1951. But the real story wasn't just about the horsepower. This hack represented something bigger. It was the opening shot in a war between racers and rule makers that continues to this day. Every time NASCAR wrote a rule, mechanics like Smokey found ways around it. Not through it, not over it, but around it. They followed the letter of the law while completely violating its spirit. The compound Smokey used was nothing special. Valve grinding compound had been around since the 1920s. It was literally designed to polish metal surfaces. The innovation was the application. The reciprocating flow pattern meant the compound worked on every surface equally, something you could never achieve by hand. The constant reversal of flow prevented the passages from becoming directionally biased. It was elegant engineering disguised as shade tree mechanics. Think about the physics for a moment. Each silicon carbide particle in the compound acted like a tiny cutting tool, removing perhaps 1/10 of a thousandth of an inch of material with each pass. Multiply that by millions of particles making thousands of passes per minute for 8 hours straight. The cumulative effect was better than what most professional porting shops could achieve with grinders in the 1950s, and it was perfectly uniform, something human hands could never match. Word got out, of course. By mid-1951, other mechanics were trying to copy the technique. But Smokey hadn't told anyone the exact compound mixture or the flow rates or the timing. They'd pump regular grinding compound through at steady pressure and wonder why their manifolds came out unevenly worn or why certain passages got enlarged while others stayed rough. The secret was in the details. The oil viscosity had to be just right, too thin, and the compound wouldn't carry enough abrasive, too thick, and it wouldn't flow properly. The pressure had to cycle between 20 and 60 psi at exactly the right frequency to create optimal scouring action without erosion. The manifold had to be positioned so the compound would drain and refresh, preventing particle buildup that would cause uneven wear. Smokey eventually refined the process even further. He started heating the manifolds to 200 degrees Fahrenheit during treatment. The thermal expansion opened up the grain structure of the cast iron slightly, allowing the compound to work more effectively. He added detergents that helped carry away removed material. He experimented with different abrasive grades, starting with coarse compounds for the initial passes and finishing with progressively finer grades until the passages were polished to an almost chrome-like finish. By the 1952 season, NASCAR had caught on. The new rulebook specifically banned chemical treatment, acid etching, or any form of internal surface modification, whether by mechanical, chemical, or other means. They'd closed the loophole. But Smokey had already moved on to his next innovation, allegedly soaking cloth air filters in nitromethane and letting them dry, giving him a hidden power boost that lasted just long enough to win a race before the evidence evaporated. The impact of this hack went beyond just racing. Word filtered back to Detroit. Engineers at Hudson and other manufacturers started paying attention to exhaust manifold design. The 1953 Hudson Hornets came with notably improved manifolds, with smoother passages and better flow characteristics. They still weren't polished like Smokey's, but they were better. The racing improvements were driving streetcar development exactly as Bill France had hoped, just not the way he'd intended. Modern racing still deals with this same cat-and-mouse game. Today's NASCAR rulebook is 200 pages long, trying to cover every possible interpretation. But racers still find loopholes. In 2018, teams were using trick spoilers that flexed at speed to reduce drag. Legal when measured in tech inspection, illegal in spirit. Smokey would have been proud. What made this hack particularly brilliant was its accessibility. Any racer with $20 worth of grinding compound and access to an air compressor could attempt it. You didn't need expensive machinery or specialized knowledge. This was democratic cheating, if you want to call it that, or democratic innovation, which is what Smokey called it. The compound itself tells a story about the era. Silicon carbide, the abrasive and valve grinding compound, is harder than any steel. On the Mohs scale of mineral hardness, it rates 9.5, just below diamond at 10. When suspended in oil and pumped through passages under pressure, each particle becomes a microscopic cutting tool. The reciprocating flow meant these particles attacked the surface from every angle, achieving in hours what would take days by hand. Here's the thing about Smokey Yunick. He wasn't just breaking rules for the sake of it. He was pushing the boundaries of what was possible with the technology available. Every trick, every innovation, every barely legal modification was really an engineering experiment. He was doing research and development on a shoestring budget, proving concepts that Detroit engineers with million-dollar laboratories said were impossible. The 50 horsepower gain from chemical porting proved something important. It showed that factory parts had massive untapped potential. The manufacturers were leaving performance on the table, usually in the name of production efficiency and cost reduction. Smokey and racers like him were showing what those parts could really do with proper preparation. Consider the economics. In 1951, a competitive NASCAR racing engine build cost about $2,000. Smokey's chemical porting setup cost maybe $100 in materials and a weekend of time. For 5% of the engine cost, you got a 35% power increase. The return on investment was astronomical. No wonder everyone wanted to copy it. But here's what really made NASCAR officials crazy. They couldn't even definitively test for it at the track. You'd need laboratory equipment to measure surface roughness. You'd need metallurgical analysis to prove chemical treatment. The best they could do was look at the manifolds and know something was different. But knowing and proving are two different things in a rulebook-governed sport. By the time NASCAR banned chemical porting, Smokey had won 9 races with his Hudson Hornets. Each win paid about $1,000 in 1951 dollars, roughly $11,000 today. But the real money came from the manufacturers. Hudson allegedly paid Smokey $25,000 under the table for his championship support in 1951. That's $275,000 in today's money, not bad for a guy with grinding compound and an air compressor. The technique didn't die with the rule change, it evolved. Racers started using the same principle on intake manifolds, where the rules were less specific. They used it on cylinder heads before installation. They found ways to chemically treat parts that weren't specifically mentioned in the rulebook. The cat-and-mouse game continued, with each new restriction breeding new innovations. Today, professional engine builders still use variations of Smokey's technique. Modern CNC porting has largely replaced chemical methods, but for certain applications, especially in vintage racing where original parts must be maintained, chemical porting remains the method of choice. The compounds are more sophisticated now: diamond paste, ceramic media, engineered abrasives. But the principle Smokey pioneered remains unchanged. What's remarkable is that this hack was discovered by observation and experimentation, not calculation. Smokey didn't have computational fluid dynamics software to model exhaust flow. He didn't have surface roughness testers to measure his progress. He had intuition born from working on bomber engines, creativity born from poverty, and the willingness to try something everyone else said was crazy. The Hudson teams that didn't have Smokey's secret were at such a disadvantage that several actually hired chemists to analyze his exhaust manifolds, trying to reverse engineer what he'd done. They found traces of silicon carbide embedded in the cast iron, but by then the damage was done. Smokey had won his races, made his point, and moved on to the next innovation. This story represents something fundamental about American racing. It's not just about who has the fastest car or the biggest budget. It's about who's smartest, who's most creative, who can read between the lines and find advantages where others see only restrictions. Smokey Yunick embodied that spirit better than perhaps anyone in racing history. In his autobiography, Smokey wrote, "All those years of racing, I never cheated once. I just read the rules better than anyone else." That exhaust manifold sitting in his shop, polished to a mirror finish by nothing more than grinding compound and compressed air, proved his point perfectly. He didn't break the rules. He just understood that what wasn't forbidden was permitted. And in that gap between the letter and the spirit of the law, legends were born. The irony is that NASCAR needed people like Smokey. They pushed the sport forward, forced innovation, created the stories that fans still tell decades later. Every time they found a loophole, it forced the manufacturers to build better parts, the sanctioning body to write better rules, and other racers to think harder. The sport evolved not despite these tricks, but because of them. Today, when you see a NASCAR engine producing 900 horsepower from 358 cubic inches, running 9,000 RPM for 500 miles straight, remember that it started with guys like Smokey Yunick, standing in a garage in Daytona Beach, watching grinding compound flow through an exhaust manifold and thinking, "They never said I couldn't do this." Modern exhaust headers are works of art, engineered with computational fluid dynamics, manufactured with investment casting techniques that produce glass-smooth internal surfaces coated with ceramic thermal barriers that Smokey could only dream about. But every one of them owes a debt to that chemical porting hack from 1951. It proved that surface finish mattered, that exhaust flow was critical, and that there was always room for improvement if you were clever enough to find it. The last Hudson Hornet rolled off the assembly line in 1954, the company merging with Nash to form American Motors. But those chemically ported exhaust manifolds? A few still exist in private collections, testament to a time when racing was as much about outsmarting the competition as outrunning them. If you ever see one, look closely at those passages. You might just catch your reflection in polished cast iron that was never touched by a tool, only by ingenuity, and a refusal to accept that the rules meant what they appeared to mean. What's your favorite piece of racing innovation that bent the rules without breaking them? Let me know in the comments below, and make sure to subscribe if you want to hear more stories about the mechanical mavericks who built the sport we love today. Until next time, remember, it's not cheating if it's not explicitly in the rulebook. At least, that's what Smokey would say.